Diffusion large language models are here, and they bring huge improvements over transformer models. Today we will cover the new big thing in AI, which is diffusion large language models. The first thing that I want to tell you is that diffusion is working a little bit different than how transformers work. Diffusion models are the best SOTA models in image and in video, and in some cases I think also audio. And right now they have not been able to capture text generation as well as transformer models, but there seems to be a push into that frontier of intelligence, and Inception Labs has created the first commercial diffusion large language model. This video is going to be a little bit more technical, but we will be using their coding chat, which is Mercury coder, and it has a diffusion effect here. So we will be testing this out as well, but I want to cover a little bit of how these things work, how they compare versus other available models in the market. And I think this video will be very interesting. You can skip ahead, like 50% of the video you can skip it if you just want to see how the chat works and how the result works in our little test. But I would highly suggest that you give this a look, because this is a new, very innovative approach that potentially in the next 1 to 2 years replace current models or become part of current models. So the first thing is this video from Mercury Labs that shows us how faster these diffusion models can generate text against typical language models, and it's so much faster really. Another thing that we have to see is here the comparison of output speed versus the coding index, and we can see here that the Mercury small coder is able to output like 700 tokens per second, and the Mercury coder mini is like over 1,000 tokens per second, so you get nearly instant answers. And here you can actually see GPT-4o Mini, CodeStral, and Cloud Haiku, which are competitive products to Mercury, and they are a lot slower in all honesty. And Mercury is a lot faster and it matches them. And again, we have to understand that this is like a new architecture and not very studied in depth, so we can expect even bigger improvements. And the big narrative here is how faster it is to actually generate all of these things. And here is a comparison of the ChatGPT versus Claude versus Mercury, and you can see that the speed is insanely bigger on Mercury. If we go here on their blog, they've got pretty much the same things, and they don't use custom chips. They do it on NVIDIA Edge 100s. So that's also big. That's also very important. And this could provide a paradigm shift, especially for smaller models starting off, because they cost a lot less train. And you can see here that for small models like Gemini 2.0 Flash Lite, Haiku, GPT-4o Mini, they pretty much match them on evaluations and in some cases beat them. So these models are small. We do not know exactly, however, how many billions parameters they got, but in all honesty it doesn't matter because the throughput pretty much shows the complexity. So small models usually have higher throughput, and this kind of seems that it matches the narrative. And we can see that the results are very, very promising on such an early iteration of this kind of training and architecture, and this is very, very nice to see. There is also a paper that was published like around 10 days ago about an open source diffusion language model which is called LADA, and I want to go over it really quickly because they compared with Llama 3 8 billion parameters. I don't want to go into the technicalities because I'm not an expert, but they use some kind of masking and attention at the first layer. So they've got this nice attention idea from transformers, but the rest of the things that happen below are like completely different. They've used diffusion instead of autoregressive. So they get some benefits of the transformer models that actually seem to work. And let's see here the benchmark. So here we can see the results and how they compare versus Llama 2 7 billion, Llama 3 8 billion, Qwen 2 7 billion, Qwen 2.5 7 billion. These are quite new models. Mistral 7 billion and DeepSeek 7 billion. So we're talking about very small models that have good performance, but we can do a really good comparison. And we can see one of the most important things to keep note of is the training tokens. If you know about the scaling laws, the more training tokens you got, it's like having more GPUs or training for longer. So it brings very good performance improvements the more training tokens that you got. And this is probably one of the reasons why Llama Llama 3 8 billion is actually beating this LADA 8 billion model in some of the benchmarks, but the difference is not that big. And you have to understand that Llama 3 is like using literature of 7-8 years, while LADA 8 is pretty unexplored territory. And in some cases, LADA is like beating the competition in some of the evaluations. And it's, if I'm not mistaken, it's also open source. So that's pretty great. And here is the benchmark results for post-trained LLMs. So this is probably for supervised fine-tuning. Some of them have also reinforcement learning. And we can see here again, very good benchmarks that match in some cases the state of the art. However, we see here that Quen is actually doing a very good job. I don't know why they split these two. I haven't looked into that, but what we have to understand is that the first results are super promising, and given the great speed up of generation, that's very, very promising. So this is something new that may be coming out, and I don't know, maybe if they scale these things, maybe they work better, or if they train them more efficiently or with more tokens, maybe they become a lot better than small LLMs. So what should we say over here? What should we test out? I don't even know if they can handle images. So let's say, oh, they can handle images. So I don't know. I don't want to give it a very hard example. So maybe what we will do is we will try to replicate this page, clone the following website, and just that. Let's tell it just to clone the following website, and I exceeded the maximum conversation length at Playground. So that's bad. All right, let's try a new coding prompt. So they give us some ideas over here, but no, I don't want that. So let's open up a new chat. Please replicate a chat LLM website. Name it AeroChat. Always return a dummy response like subscribe. Make it look dark, modern, but professional. All right, so we're going to check it out. Let's see what the result will be. And it says subscribe. Okay, so maybe my prompt was not good. Please code a chat LLM website, and you see that it actually is generating super fast. This was insane, and they also got a preview over here, so that's nice. Okay, so we've got this chat over here. It's missing some things, like it's not very organized, but the generation speed indeed matches the expectations and what they promise out of it. So I don't know, what else can we tell it to do? So create a landing page. All right, so we are going to ask it to create a landing page, and you can see how fast it does this generation. And yeah, the landing page doesn't seem bad. It looks good. It has features, home contact. Okay, so the generation speed is actually insane. You can literally iterate nearly at real time. Imagine typing something and you get an instant response and just work on it more and more. All right, let's improve the website to sell a AI course. All right, so we're going to ask it to improve the website to sell an AI course, and let's see what the landing page will be. AI master course. You've got these things: sign up, key features, sign up for the course. All right, add the following one: FAQ, pricing, a nice catch, hero phrase, hero section, animations. So let's ask it that. I'm not going to test it to the limit. I'm not really interested in testing it to the limit. Again, it's a small model. This is something that we have to understand. We're talking about a very small model that it is actually doing an amazingly good job. All right, I like this. It has pricing, FAQ. Yeah, that doesn't look bad at all. One of the things that we can see here is that probably it has a cutoff age of 2023, so it's not newly trained. So we could possibly expect a new iteration. All right, so I'm going to ask to create a ping pong game. I'm just going to ask it those general questions that they have over here. Probably it works super well for these. So this is like ping pong game that is completely automated, I think. And it has a game loop. So let's try another prompt. Let's implement the game of snake. Make sure the snake doesn't move fast. So we're going to check out these prompts that they got over here. All right, let me see if reset game worked. Okay, it worked. That's nice. All right, write a simulator for 5 bolts bouncing, make collision physics realistic without gravity. Let's check that out. And I think these prompts are quite nice to test out. All right, that looks okay. Oh, it has, real physics. Okay, so I could actually use these prompts for other tools as well in the future. So create a detailed guide to object-oriented programming. Now that's going to be interesting. Let's check that out. One of the best use cases for LLMs is using them to learn things. And whoa, they create so many things. Oh, that looks nice and super fast. So you can literally get so much fast responses. All right, use meaningful names by mastering these concepts. All right, create a JavaScript animation of Earth orbiting the sun and of the moon. All right, let's check it out. And you can see real-time generation. Hopefully this is not a scam. But yeah, okay, looks nice. Illustrate a forward diffusion. Oh, that's interesting. This can show us how diffusion actually works. Okay, so you can see here it starts with noise and starts to denoise the image. But this is the forward process where you have the denoised image. Denoised image means not corrupted, and you corrupt it, and then you pass this image and do the inverse to learn how to get a noisy image, an abstract whatever image, and turn it into an actual working image that makes sense. All right, so this tool looks good. This tool really looks good. Create a Super Mario-like platform game with coins on the browser. All right, let's check it out. Final question I'm going to ask it. Game creation is one of the things that have been so well known lately. So how am I going to test it up? Oh, you need Node.js. All right, so it cannot check this out because it needs Node.js. All right, so that makes sense. Okay, make sure to allow me to use it in browser without setting up web servers. All right, so let's check out if it can make it work. We're experiencing high load. Your request has been queued. Please wait a moment. All right, I guess that's good for them. All right, so how can I play this game? Oh, so this is like, oh, all right. So how can I jump? Okay, so the jump is really small. All right, let's ask it. Make sure to allow the player to jump higher. Okay, so let's see if it allows us to jump higher. The jump should be as lengthy to reach the coin. Okay, so let's see if it can actually fix the game. Nope. So this is probably a miss, but again, this is one of the first iterations of diffusion language models, and I really liked. So final question. I'm creating a website with utilities for programmers and investors. Provide me with 20 unique ideas to implement, find product market fit. Why not? You know, we have this NoFX services website down below in the description where me and my friend, we build useful utilities for developers and people that invest or want to have productivity, and you can check it out over here. So we're trying to find ideas to create things. So what it says, code snippet library, a database of code snippets categorized by language and use case, product management tools, investment analysis tools, market research reports, that's also interesting, virtual reality coding environment, AI powered code review, crowdsourced bug bounty platform. Nice. Cryptocurrency investment guide, we go to one of these actually, open source project finder, tech news aggregator, DevOps automation tools, blockchain education platform, mentorship, matching service, startup founding tracker. Right, these are interesting things. Nice responses. I really like this website. Seems interesting. Check it out and tell me if you actually like it. Thanks so much for watching. I will see you in the next video. Bye.